Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 26, 2025, about 2 days ago. It replaces centralized orchestrators with a peer-to-peer, message-driven runtime and delivers between 2 and 15 times higher data generation throughput on large clusters without hurting output quality. The paper is titled Matrix Peer-to-Peer Multi-Agent Synthetic Data Generation Framework, and as we will see later, the implications for scaling synthetic data pipelines for large language model training are pretty significant. Alright, the introduction set up the motivation for removing the central orchestrator, and Figure 1 shows how the whole agentic data generation system hangs together. The top right block, labeled Agent Environments, runs the multi-agents and the control logic that decides whether a task continues or goes to the sink. The left side configuration block defines prompts, data schemas, metrics, and the orchestrator style. The bottom left data store holds seed data, generated data, and assets that flow into the agents. The bottom center cluster management block exposes large language model services and containers, while the monitoring block on the right tracks performance and logging so large runs stay healthy. Well, Figure 2 focuses on the traditional centralized orchestration setup. The large orange box represents a single centralized agent environment that owns all workflows and routes every decision through one orchestrator component. This orchestrator sits between Agent 1 and Agent 2, controlling their order and accessing both the input-output store and the large language model or container service. Because every message and model call passes through this central hub, the design becomes a scalability bottleneck once thousands of workflows run in parallel. Alright, Figure 4 compares throughput as concurrency rises for the collaborative reasoner baseline and the peer-to-peer agent system. The orange peer-to-peer curve climbs almost linearly up to the highest concurrency, which shows that additional worker tasks keep translating into more data per minute. The blue baseline curve flattens and then drops, so the single orchestrator starts throttling performance instead of the hardware. So while Figure 4 showed scaling trends, Table 1 puts concrete numbers on the large cluster run. The peer-to-peer agent finishes in about 4.3 hours versus just over 9 hours for Coral, while running more than twice as many concurrent tasks. That setup yields around 1 billion trajectories and roughly 2 billion tokens, about 7 times the token throughput. Crucially, agreement correctness stays essentially identical, which means the speedup does not sacrifice data quality. So the previous table quantified gains for collaborative reasoning, and Table 4 now does the same for large-scale web document curation. The peer-to-peer agent and RAID data both run about 14,000 concurrent tasks, but the peer-to-peer agent processes roughly 25 million documents versus 9 million. That difference yields about 3 times more questions and nearly 3 times more tokens overall. Because those extra tokens arrive over a similar wall clock, token throughput roughly doubles from about 2.8 thousand to about 5.9 thousand tokens per second. Okay, after the web curation results, Table 5 turns to the tool use benchmark Tau2. Both systems run for about the same wall clock time, but the peer-to-peer agent handles roughly 3 times more concurrent tasks and over 10 times more trajectories. Total tokens jump from about 11 million to 185 million, so token throughput rises by a factor of 15. Average reward stays effectively unchanged, which means this massive speedup preserves task quality. So the big takeaway is that moving from a centralized controller to peer-to-peer message passing lets multi-agent data pipelines hit 2 to 15 times higher throughput without losing quality. That change makes billion-token synthetic datasets much more practical on shared clusters. That is it for this episode of AI Research Roundup. I am Alex. Thanks for listening.